Okay. So you guys in about the 5th grade were taught factor trees. You all know what they are. Mrs. Bagcrumble used them. She drew them, or he drew them in a myriad of different ways, but you drew them. You know what they are. You've used them. But much like all math in the British Columbia, the way we teach math in BC, they showed you that in grade 5, and you thought that's what it was, that's all you were doing, right? I'm going to make a factor tree, and you were done, and you got your gold star, and you were really happy, right? But of course, those factor trees have an application. They are used in higher level math, but we don't tell you that in the 5th grade when we show it to you for the first time. So you do it, you learn it, you get it in your head, and then you don't use it again for 5 years. And now all of a sudden we're coming back to say, hey, remember these things from 5 years ago? Well, they're going to be used right now. All right? I don't like it, but I don't make the rules. So we're going to use them again, those things you made back in the 5th grade. But before we do that, I need to make sure we're aware of a couple of things. The number one thing we need to be aware of is what is a prime number. Prime numbers are very important because they are extremely powerful numbers. As a matter of fact, one day when aliens come to communicate with us, they are going to communicate with numbers. They aren't going to communicate with letters. But we'll wait and see. Who remembers what a prime number is? Pardon me? Nobody? Not one person? Thank goodness we spend so much time on math before grade 10. All right. A prime number is any number which only divides by 1 and itself. So this means prime numbers have 2 factors. What's a factor? Who remembers what a factor is? Anyone? Was a factor. Oh, Connor! Somebody I taught math to, thank goodness.
Factor is what you multiply by.
Excellent. Factors are the numbers we multiply. So, 3 times 2 equals 6. These are the factors. Everybody cool? Okay. So prime numbers are real important for a lot of math. I recommend that you memorize the first few of them. When I say few, I mean like up to 20. There's not that many. So I recommend you memorize these. I'm going to write them over here. 2, 3, 5, 7. What's the next one? No. You missed one. 11. Then what? 13. Then what? 17. 19. I recommend you have those in your head ready to go. The next one's 23. The next one after that is 29. The next one after that is 37. 31, then 37. Then 41, then 43, then 47. There's no pattern to them. That's why they're so wicked awesome. There's no way to guess when the next one is. Mathematicians just found the biggest one ever. It's up in the billions. there is a number somewhere way up in the billions that there's no way to get to it except to multiply itself by 1. It's got no other factors, which is pretty cool when you think about it. At least when I think about it, I think it's cool. So the reason these are powerful is, like I say, they are the ends of our branches, because you can't get any smaller than there when you're drawing a factor tree. The most powerful prime number is that one. Why? Look at the list. What is different about 2? It's even. It's the only even prime number. Why is it the only even prime number? Because every other even number divides by 2. So that's what makes that very powerful. Now, I'm going to draw a factor tree probably very similar to what you have seen before. And then I'm going to draw a different way to do it. You can choose which one you like most. Some of you won't even use these past today. But most of you will have seen a factor tree that looks something like this. You take 54 and you choose 2 numbers that are factors of 54. What are any 2 numbers? 9 and 6. Right? Does 9 have more factors? What? 3 times 3. Does 3 get any smaller? Yes or no? No, because it's a prime number. Does that 3 get any smaller? No, because it's a prime number. So when you get to a prime number, I like to circle them because that's where the branch ends. What about 6? What does it break down into? 2, that's a prime number, and 3, that's a prime number. Yes? All of you have seen this before, right? Okay. We're going to go one step further with it. When you get to everything circled, I want you to use exponents to write out what we call a product of primes. And what that means is you take all your prime numbers and you multiply them together. So this is 2 times 3 times 3 times 3. Yes? 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Is everyone cool with that? But this is late. This is what we've really done. But math guys are lazy, aren't they? So what would a math guy write instead of that? What do math guys like to do instead of writing that? 2 times 3 cubed. Right? Everybody cool? Okay. Now you guys, this one over here, if you wish to do a factor tree like that, go ahead. I'm going to do this in a different way. Okay? This is another way that you can use to do prime factors. This is the way I was taught. I look at 162 and I see that it divides by 2. 2 goes into 16 8 times. 2 goes into 2 once. Now I have 81. I know that 81 will divide by 3. That gets me 27. I know 27 will divide by 3. That gets me 9, 3, and 3. And you can see that on the outside of the divisions, I have all of my factors. Does everybody see that? What is the product of primes here? It's 2 times 3 times 3 times 3 times 3, yes? And how would math guys write that? 2 times 3 to the 4th. Is everybody cool with factor trees? Yeah? Now, I like to take a second here to do something that I don't normally do. I don't normally like all those little tricky McTrickleton things that you guys have learned, do I? 9 times 7. 63. I don't like that. Right? I hate them. There's the other one with your knuckles. I hate them. They make me want to just, yeah. Okay? I don't like them. But I'm going to give you a couple here because for this there is some tricks that are helpful. It wasn't that funny. I mean, I appreciate it. You're a very good audience, Jordan. I'm going to give you a couple of things here because there is some good stuff here. Notice we're doing a lot of division, yes? And since all of you learn silly little tricks like that, instead of learning your times tables and memorizing them, most of you, because you don't have your times tables memorized, have a lot of trouble doing division. A lot of trouble. So I'm going to give you a couple of little hints that will help you out. Hint 1. If your number ends in 0, 2, 4, 6, or 8, you can divide by 2. You already knew that one, right? Hint number 2. If the digits in your number add to a multiple of 3, you can divide by 3. What do I mean by that? 138. Can I divide that by 3? Yes, because 8 plus 3 is 11. 11 plus 1 is 12. 12 divides by 3, so I can divide that by 3. Everybody cool? Some people haven't actually heard these tricks, which boggles my mind. You were taught all these crazy tricks to multiply, and then nobody taught you any tricks for division, which makes no sense to me. You were never taught the 63 thing? So you have your times tables memorized, Daniel. Exactly. If you had them memorized, they'd still be there. Right? By the way, if there's one thing you can do for yourself that will guarantee you an easier time in Math 10, Math 11, and Math 12, it's to rememorize your times tables. Not just know them, memorize them. So if I say any two numbers from 2 to 12, you can have me the answer by the time I finish saying the second number. Not this. What's 6 times 7? 42. Not that. What's 6 times 7? 42. That's how fast. You get to there, all math is easy. Just a little hint. The next trick that is helpful is if it ends in 0 or 5, we can divide by 5. Next trick. If your number divides by 2 and it divides by 3, it'll divide by 6. And that's where I want to stop. That's enough to get you through everything in the 10th grade. There are some more tricks like that. There's one for 9. There's one for... I can't remember the rest because I don't use them. But there are some that will help you out. If you didn't write them down, no big deal. It's recorded. So I want to talk about all of these things here, and I'm going to be highlighting things. If I highlight them, they are words that I'm going to use all the time, and they are going to continue to come back and come around and show up in math again and again and again and again. So make sure you actually know what they are. Greatest common factor, GCF. You know what all those words mean. What does greatest mean? The biggest, right? So the biggest number. What does common mean? Close. Shared, right? We share. This room is common to all of us for Block B, right? Because every Block B, we're all in here. So we share this room. The building is common to us all day, yes? All right. So the greatest shared factor, and that is simply the largest number which divides into at least 2 others. Everybody cool with that? Now, notice I've used prime factorization right there. We can find a GCF using prime factorization by multiplying only the common prime factors. All right, so we're going to do that right now. Find the GCF of 54 and 62. So 54 was 2 times 3 cubed, right? We just did that up at the top of our page, right? And 162 was 2 times 3 to the 4th, right? Everyone agrees? Now, I told you you can find a GCF by multiplying only the common prime factors. Is 2 in both of them? Yes or no? Yes. So our GCF must include 2. Everyone agree? Okay. Is 3 in both of them? How many 3s? There are 3 3s in both numbers, yes? So 3 is common to both of these 3 times. So what is 2 times 3 cubed? We know it to be 54. Now, is 54 a factor of 54? Yes, because 54 times 1 is 54. Is 54 a factor of 162? Yes. 54 times 3 is 162. Because 50 times 3 is 150. 4 times 3 is 12. 150 and 12 is 162. Everybody cool? Everyone can do that? Everyone sees what we did there. We only counted what was common. That's why this fourth 3 did not get counted. Is everybody good? Awesome, possums. Now, the next thing we have is lowest common multiple. You already have done lowest common multiple in your life, but you didn't call it that. You called it lowest common denominator. Because that's how we found them, yes? If I have to add, don't write this down, 3/5 plus 4/7, can I do that? As it's written there. No, I need a common denominator. And what is it? 35. That is the lowest common multiple of 5 and 7. Why is it a multiple? Because 5 multiplied by something to get 35. 7 multiplied by something to get 35. Cool? Now, the shortcut your teacher probably told you is if you don't know, just multiply them together, right? But over here, are we going to multiply 54 times 162? Can we do that in our heads? No, it's a giant number. So we're not going to do that. In grade 4, when your teacher taught you fractions and lowest common denominator, he or she always gave you little tiny numbers that were easy to work with, right? But we know from yesterday, numbers go up to what? Infinity. Are those numbers that big, easy to work with? No. So we break them down into little numbers that you can work with. Prime numbers. Cool? So, a lowest common multiple is the smallest number which shares both, shares factors with the originals, with the original numbers. It'll show up in a minute. Okay. And again, we're going to use prime factorization. Now this one is tricky. GCF's easy. Everybody understands GCF. But LCM causes problems. In LCMs, we multiply every factor once without repeating. So here's what I mean by this. I did the GCF in black, GCF, and I'll do the LCM in blue. We start with 54. We know it's 2 times 3 cubed, yes? Then we add 162. Now we already know the answer is 162, right? Because we checked it from factoring. 54 times 3 is 162. 162 times 1 is 162. We know the answer is going to be 162. But we're going to write it out anyway. Now, our LCM, we count everything once without repeating. How many 2's cover both guys? How many 2's do I need to write to account for all the 2's? No repeating. So how many 2's do I need? I need a single 2, because that 2 covers both of these, yes? How many 3's must I write to cover my maximum amount of 3's? If I write 3 to the 3, I don't cover that fourth 3. So how many 3's must I write to cover all of my 3's? 7 will repeat those 3. So how many 3's must I need to write here? 3 won't cover all of them. 4 will cover too many. Or 7 will cover too many. So how many 3's do I need? He waited patiently. Maybe it will help if I write it out here. 2 times 3 times 3 times 3. 2 times 3 times 3 times 3 times 3. How many 3's do I need to make sure I count every 3 once? 4. Because there's 1 3 there, a second 3 there, a third 3 there, and I got to count this fourth 3 because I got to count everything once. So this is 3 to the 4th, which equals 162. This one causes people problems. I don't know why. You count everything once, and once only. So 2 covers all those 2's. 4 3's covers all my 3's. Got it? If you need to write it out, go ahead. Let's turn the page over, and let's work these. Use prime factorization for 36 and 120. So you got to make 2 factor trees, yes? Go ahead and do whatever way you do your factor trees. Some people like to do them sideways. I don't care. Whatever works for you. I'm going to go sideways with 36. And then I'm going to go up and down with 120. GCFs will be black. LCMs will be blue. If you need to flip back to your notes, flip back to your notes. It's okay. Or just look up here. Make sure you write all this out, though. When you're done writing, stop writing and pay attention. My GCF has to count what? The commons or everything? What does GCF need? The commons or everything? Commons. So look at our list. Are there some 2's that are common? How many 2's are common to both of them? I'm right here right now. How many 2's are common to both numbers? How many 2's does 36 have? Answer the question first. Why? Don't. How many 2's does 36 have? 2. How many 2's does 120 have? 3. So how many 2's are common to both of them? I'm walking up to both of these numbers. I say, give me all your 2's. How many can you give me? You're 36. You can give me 2. How many can he give me? 2. That's the same as you, right? That's what's common. You share 2 2's, right? So the GCF must have 2 2's in it, yes? How many 3's? One. Any 5's common to both? So do I count the 5? No. 2 times 2 is 4. 4 times 3 is 12. So that's our GCF. Does everybody understand how to find GCF? You just look at what is shared between your numbers. You don't look at any extras. What do you need for the multiple? You need to cover everything, yes? Okay. So, how many 2's will cover all of my 2's? 2 cubed. How many 3's will cover all of my 3's? 3 squared. How many 5's will cover all of my 5's? 1. 2 cubed is 8. 3 squared is 9. That's 72. 72 times 5 is 360. That's my LCM. Can everybody do this? Okay, prove it. What is your factor tree for 18? Draw it. Don't say your factors out loud. I'll wait a moment and then I'll ask for your factors. And somebody who's feeling brave can offer them up. I'll wait a second for you to draw it out. Anybody feeling brave? This is the easy part. Gets you out of the tough stuff. Daniel. 6 times 3. Now, is 6 a prime number?
No.
So what's your next branch going to be on the 6?
3 and 2.
Right. So Daniel has 2 times 3 squared, right? So you had 6 times 3, and then 2 times 3. 2 2's and a 3, right?
Yeah.
Or 2 3's and a 2, right? Great. What's 24? Pardon me? 2 cubed times 3. Everybody cool? Because 2 cubed is 2 times 2 times 2, which is 8. And 8 times 3 is 24. Everybody got the factors? Okay. For GCF, what do I need? Only what's common. How many 2's are common? 1 2. How many 3's are common? 1, 3. What's 2 times 3? 6. So my GCF is 6. My LCM, I need to count everything, yes? How many 2's will cover all of my 2's? 2 cubed. How many 3's will cover all of my 3's? 3 squared. 2 cubed is what? 8. 3 squared is what? 9. What's 8 times 9? 72. Is everybody good? All right. Let's try 45 and 75. Oh, they end in 5. That makes them real easy to do division for, right? Go. What are my factors of 45? And my factors of 75. I'll wait a moment to let you draw your trees. Or your steps, or whatever the heck you use to find factors. Would anyone like to volunteer when they're ready? Haley. 72. Nobody wants to take a chance on their factors here. Jordan. What are they? Yeah. Right. I like to write the littlest number first, but does it matter? Of course not. 3 times 5 squared. So my GCF is what? Everything common. How many 3's are common? 1. How many 5's are common? 1. What's 3 times 5? 15. Done. LCM is everything once. How many 3's will cover all of my 3's? 3 squared. How many 5's will cover all of my 5's? 5 squared. What's 3 squared? 9. What's 5 squared? 25. 9 times 25 is 225. Now, this is about when somebody usually notices a pretty big hint for lowest common multiple. Has anybody noticed a pattern in all 3 LCMs? I'm going to shrink it down so I can have them all on the screen at once. Has anybody noticed a pattern in all 3 LCMs? Anybody? Anybody? I'll do a little highlighting. Oops, I didn't want to erase those. What was that, Jordan?
It contains all the exponents.
You have to use the biggest exponents. And then, what if there's something left over? Do you have to include it? LCM counts everything once. You do have to include anything left over. Cool? Okay, do 35 and 84. What's 35? That's an easy one. 5 times 7. Are those both prime? Yep. What about 84? That's a little harder. I'll let you build your tree because it takes a bit of time to do 84. 2 squared times 7, that's 28, times 3. Everybody cool? Okay. So what's the GCF? What's common to both? Is there a 2 in both of them? Nope. Is there a 5 in both of them? Nope. Is there a 3 in both of them? Nope. What's the only thing shared? 7. What about LCM? I got to choose the highest exponent for everything with an exponent. So 2. How many 2's do I need? 2. What about 3? How many 3's do I need? 1. How many 5's do I need? 1. How many 7's do I need? 1, because the biggest exponent for 7 is 1. And then I just multiply that out. 4 times 3 is 12. 12 times 5 is 60. 60 times 7 is 420. Which usually makes people giggle around there. Only one giggler this year. Oh, 2. There we go. All right. Now, what if there's a third number added? Does anything change? Of course not. I'm going to add 30 to that one, and I'm going to add 16 to that one. Does that change your GCF and your LCM? Of course it does. I have 45 and 70, so I'm just going to delete this to make room. I've got my 45, I've got my 75. So what do I have to add here now? 30. Do I change my methods? No. I found prime factors of 45 and 75, so now I find prime factors of 30. What are they? 3 cubed is 27. 3 squared is 9. 9's not a factor of 30. 2 times 3 times 5, right? Okay. So what's my new GCF? I count everything that's common. Is there a 3 in all of them? How many 3's? 1. Is there a 5 in all of them? How many 5's? 1. Is there a 2 in all of them? No, so I don't count 2. So what's my GCF? It's still 15. What's my LCM now? Count everything once. Do I count that 2? With what exponent? No exponent. 1, because there's only 1, 2. Do I count the 3's? With what exponent? Squared, because that's the biggest exponent I have. Do I count the 5's? With what exponent? 2. 2 times 3 squared is 2 times 18 times 25, which is 36 times 25, which is 900. Is everybody good? Okay. What's going to happen over here? What is 16? 2 to the 4th. So what is my GCF? Do I count 2? No, because it's not common. Do I count 5? No, because it's not common. Do I count 3? No, because it's not common. So what is my GCF? What's the only thing that's common to all of them? Still, is 7 common to all of them? So what's my GCF? 1, because there isn't a greater common factor than 1. Agreed? What is my LCM? I have to count everything by the highest exponent. So, how many 2's do I need? 2 to the 4th. How many 3's do I need? 1. How many 5's do I need? 1. How many 7's do I need? 1. 16 times 3 times 5 times 7. 16 times 3 is 48. 48 times 5 is 240. 240 times 7 is 1,400. 1680, I believe. Just quick check. Whew! All that in brains too. Is everybody good? There's nothing more to it than that. Now listen to me. Unlike previous years when you learn something like this, this is the first step, not the last. So if you can do this, awesome. You're ready to move on. Up to this year, this would have been the end, yes? I can do prime factorization. And you'd be like, yeah, and I'd give you a gold star and we'd be happy, right? This is the first step in a very long journey. So be comfortable with it. How do you get comfortable with it? The same way you get comfortable with everything. By practicing. Go. You know it, sister. When's it due? Tomorrow is cumulative day. Friday's professional day. Monday. 4 days to do that. Is a 4-day break a time that I might consider a homework check afterwards?
Definitely no.
I wonder. Parade to the bathroom can begin.